Good evening, students. Am I audible? My screen is visible.
Yes, sir.
Yes,
Yes,
sir.
sir. So today we are going to discuss about operating system. We are going to start our new subject that is called operating system. Fine. Can you just tell me what is operating system? Any idea about operating system? What is operating system?
Yes,
Mm,
sir. Operating system is interface between the user and systems hardware.
User and hardware. Very good. That absolutely true. So I can say an operating system, first of all, is a system software. We have different type of software. This is called system software that works as an interface between the user and the hardware. So suppose we have the user here, we have the hardware here, and here is the operating system. Okay, so it is the interface between user and hardware. Can you just tell me why there is a need of interface? Why not user can directly interact with the hardware?
Some
sir,
communication needed, sir.
sir, it is managed to resource hardware and software, I
That is
think.
absolutely true. That means it manages all hardware resources like CPU, memory, memory like input output devices. Fine. So we, or we can also call it as it is a resource manager who manages the resources. Resources may be CPU, resources may be memory, resources may be IO devices, input devices, all this stuff. Fine. That is the main task of operating system. Now my question is why there is a need of operating system?
Sir, it is work to performance better
Okay.
computer.
Might be difficult to work directly with hardware, so better OS is available.
Sir, better performance.
Better performance. Okay. Very good. See, my dear ones, you can understand like this. Suppose that someone asks you to drive a car. Now, to drive a car, at the same moment of time, we have to take many decisions, right? Like we are just seeing the left or right, change the brake, push the accelerator, and all this stuff, all the things we are going to do in a same time in a multiple way, right? Suppose that user only want to, or if I want to execute my activity, if it requires only one instruction to execute at the whole instance of time, then there is no need of OS. Fine. But the point is, because at the same moment of time multiple functionalities are going to be implemented, in that case, to make a synchronization between all these activities, we require operating system, because user cannot do all these tasks by alone. Are you getting my point? So that's why we are just requesting to the OS, and it's the task of the OS to implement all these functionalities. So it is doing the task behalf of us. Are you
सर
getting my
वन
point?
डाउट
Huh?
सर एक मिनट सर एस्कीप हो गया सर सिंक्रोनाइजेशन मतलब क्या होता है थोड़ा सा समझा दीजिए
Okay, synchronization means what? See, sync means suppose that we are standing on a traffic light. अगर लाइट नहीं होगा तो फ्रॉम द ऑल साइड्स ट्रैफिक आएगा जाएगा, राइट? बिकॉज वी आर
यस
नॉट इन अ सिंक मैनर. सिंक मीन्स जब भी लाइट ऑन ग्रीन होगा हम जाएंगे और रुकेंगे. दैट इज द पॉइंट ऑफ सिंक्रोनाइजेशन.
सर इट इज वर्क टू मैनर मतलब स्टेप बाय स्टेप प्रोसेस आई थिंक
It is,
स्टेप बाय स्टेप प्रोसेस
you can say, right?
यस
So that is the main task of operating systems. तो operating system क्या करता है? It manages all the resources. Like we have one resources, but request for that resources is by many of the users to whom that particular resource has to be allocated. This decision is taken care by operating system. Second thing, whenever we are going to execute something, that has to be in the part of main memory, because CPU always interact with the main memory, not with the secondary memory. Okay. So in the main memory, memory is divided into blocks. Now in which particular block our data are going to be stored? That means suppose that this is the memory, and memory is divided into blocks. Now suppose that already in this block some data is there. You want to execute some data, that's why you have to bring that data into the main memory. But if that thing is going to be override here, then
Hello,
it
sir.
means we have just loss of the data.
एक्सक्यूज मी सर.
Uh-huh.
सर इस कोई लॉबी में है तो उसको अलाउ कर दो सर.
Oh, oh, oh. नहीं है कोई भी. You can see. But
ओके सर.
oh, नहीं है एक है गोसिक. थैंक यू. बट आई थिंक तो इतना पहले वो क्यों आ गए थे? वेटिंग इज ऑफ. ओके. Anyhow, so that's the point. So it's the task of the operating system to put all those command instructions in a empty block or empty cell of the memory. Are you getting my point? So it is a resource manager. Now the second question is, what are the types of, that is very important, types of operating system.
सर कैन यू रिपीट द क्विक, आई मीन रिसोर्स मैनेजर.
Uh-huh. Because
कैन
it resources the it manages the resources may be CPU, main memory, input devices, output devices. How it can manage we will discuss in the upcoming lectures. Okay.
ओके सर. ओके.
Now the first operating system is called batch operating system. Can you just tell me what is batch operating system? So a batch operating system collects similar job together and execute them in batches without user interface or user interaction during execution. That means EXN means execution. So I think I need to write. Fine, my dear students. Suppose that we have, these are the A, B, C, and D. These are the similar type of jobs. Even E, F, G, H. So we just make a batch And now these similar type of the jobs are executed one after another. Then these job finishes, then we just make a new batch, and then these batch is going to be executed. Okay, that's why in a batch form, a batch operating system collects similar jobs. That is the important point. Fine. Yes or no?
Yes, sir.
Sir, the jobs in a
Yes, sir.
single batch are operated simultaneously or not?
Not a one after another, because it's not the multi-processor, na? It's single operating system.
Okay, okay,
So
sir.
can you tell what is the second point?
Sir,
User interaction
1 minute, sir.
which you written.
Sir,
1 minute वेट
hello?
ना, जब कोई और बोल रहा है तो आप कह रहे हो 1 minute, वाई इज इट सो? यस प्लीज
सर अगर दोनों जॉब
वेट
एक ही बार
करो, किसी और को, आपके टाइम पे कोई और बोल रहा था, आपने बोल दिया वेट करो. यू कैन
सॉरी
वेट नाउ.
सर, सॉरी सर.
What is that second line which you have written? That user
टुगेदर
interaction.
एंड एग्जीक्यूट देम इन बैचेस
Yes, sir. वो second line है ना WO user interaction वो
विदाउट.
वो
यस नाउ
सर
नेक्स्ट वन.
अगर दोनों जॉब सर एक ही बार एग्जीक्यूट किया जाए तो फिर क्या होगा?
दोनों
जॉब एक ही बार सिमिलर जॉब, जैसे एक जॉब 1 by 1 एग्जीक्यूट होगा जैसे सिमिलर जॉब होंगे.
हैं?
अगर दोनों ही जॉब एक ही बार एग्जीक्यूट हुआ मतलब बैच में
एक
जाएंगे
ही बार मीन्स
ऑपरेटिंग.
एक साथ.
हाँ जी.
एक साथ नहीं हो सकता, बिकॉज ऑपरेटिंग सीपीयू एक ही है ना, प्रोसेसर एक ही है,
ओके
सिंगल प्रोसेसर मशीन है दिस वन. फाइन. So I think the examples are like at the starting time, early IBM mainframe computers are the example of batch operating systems. Fine.
Yes, sir.
But the problem is like debugging is very difficult in this case, and they are very slow. No immediate output is there. That's why we move on the next type of operating system, that is called time sharing operating system. In time sharing operating system, it allows multiple user to share the systems within a time frame, resources simultaneously, giving each user, that is important, a small time slice. That is called time sharing operating system. So it allow multiple user to share the resources at the same moment of time, but each user can use that resource for a fixed duration of time. That's why in this case, I can say CPU switches very fast between the tasks. So here we get the feature of multitasking. And because it is switches very fast, that means it provide quick response time. Any doubt? So examples
No,
are
sir.
Unix operating system. Right? Next, this is multi-programming. The two most important definitions is one is multi-programming, one is multitasking. So we are talking about the third one, multi-programming operating systems. So in multi-programming operating system, my dear students, a or I can say a OS keeps multiple program in memory and executes them by switching between when one is waiting. So multiple programs is going to be stored in the memory. Still we have only one processor, keep in mind. But now this is program 1, this is program 2, this is program 3, this is program 4. They are in the main memory. Rest our code is present in the secondary memory. So whenever something is going to be executed, that has to be present in the main memory, my dear students, because CPU only interact with the main memory. And the name suggests multi-programming. It means in the main memory, multiple programs are there. So when one program is finishes, immediately because the next program is there, and that is also present in the main memory. So no switch time is required here. We are not bothering about the switch time. Switching means something is going to be in and out, swap in and swap out consideration. CPU always has something in the main memory, so that CPU are bit busy with executing those tasks. Okay.
Yes, sir.
Yeah. Next is multitasking.
Sir, example for multi-programming.
Oh, example for like modern operating system, they are so multi-programmed. Like I can say modern Linux, which supports like multi-programming, and IBM also make one operating system, that is IBM OS2. These are the examples. The multitasking operating system. So in this, it allows a single user to perform multiple tasks simultaneously. Fine. Multiple tasks. Multitasking is multiple tasks a single user can perform simultaneously. Can you just tell me, oh, we have only single CPU, then how we can execute the multiple tasks?
No, see, sir, we have multiple cores in the CPU. We have multiple cores, sir, in the processor.
Multiple cores. Okay. That is right.
Sir, sir,
So
जैसे
some
sir
cache memory.
कंप्यूट कंप्यूटर वर्क सर
Eh?
विंडोज कंप्यूटर वर्क विंडोज जैसे मल्टीपल वर्क
Okay. That's right. I can say because we have multiple cores. But in general, what happen? Multi. If I talk about multitasking, fine. So suppose that a user want to execute, we have only single processor, and suppose that Suppose that these like single processor we have and we are executing the different tasks, then the tasks are executing with a very high speed such that we are unable to judge it, that their tasks are executing in a time sharing manner. Fine. We are thinking that they are executing simultaneously, but in general they are executing one after another in a time sharing mode. But they are with such a high speed that we think that they are executing parallel. Okay, so that is multitasking. So current Windows operating system are the examples of multitasking. We can perform the multiple task like YouTube is running, Facebook is running there. So these are two different applications, but they are executing or running simultaneously. But with a single processor, how is it possible? Fine, that is the main point. Mac OS is there. So these are multitasking operating system. So multi-programming, multitasking is very important, and the next important thing is real-time operating system. This is also very important. Can you just tell me what is a real-time operating system?
That means the output will be guaranteed in a certain time, in a certain amount of time.
In a certain amount of time. Very good. Means they are a bit strict with time constraints. Okay. So output, it produced within a strict time constraints. Fine, time constraint means deadline. Are you getting my point? Like mainly they are like used in, I can say, these are the special type of operating system like launching a missile and all this stuff. In these cases, these are very important. These are the real time operating system where delays, there is no such delay. Okay, everything is going to be executed within the deadline. So we have mainly two types of real time operating system. One is hard real time operating system, and second one is soft. One is hard. Hard means like it's more or less related to hardware. Soft means software. Soft real time. So if I talk about hard real time, basically these are used in defense or during missiles, and talk about, so one more point is like in this case, whatever the deadline we set, that cannot miss. Means that means missing a deadline just mean failure of system. But whereas in the case of soft real time, missing deadline is allowed, but it affects the performance. Fine. In general, overall, In real time operating system, everything has to be completed within the deadline. But here deadline missing is allowed, and as if it is allowed, then it also affect the performance. Means we are try our best to achieve the deadline. Mainly like you can see the audio video streaming. Like if we are just connect with the Zoom, there is a chance that it not works properly. Maybe I'm whenever I'm talking about, are you able to understand or not? There is a bit delay. Fine, that's the main point. One more is distributed operating system. By the name also, like when multiple computers or group of computers are connected and they look like as a single system to the user, then it is called distributed operating system. So this is the operating system which manages a group of connected computers and makes them appear like a single system to the user. Mainly, it is used like the main functionalities like load balancing, and the resources are shared across the multiple systems. That's the distributed operating system. That means resources shares among multiple systems, mainly used for load balancing. Yeah, or it has the feature of load balancing. Right? Example is AWS or Microsoft Azure OS layer. Other than that, like still we have many other more operating system like the Android operating system, network operating system, where like which is like executing on a server and provided the services. Like in the case of file sharing, in the case of printer sharing, these are the answers. Mobile operating system is there, which are there in our smartphone or tablets. Fine. One is embedded operating system, but we are not going to discuss this one. Fine. Like yeah, one is I think I miss multiprocessor operating system. Multiprocessor OS. Fine. Like basically it supports system with multiple CPU. Here multiple CPUs are there. So they are like high performance parallel processing and tasks are executed fast. Any doubt?
No, sir.
No, sir.
Fine.
Sir,
So
what question, sir? How will we question?
straightforward definition type questions.
Hmm.
So they just give you the definitions. What is that, and you have to pick up.
Okay, sir. And how many topics are in operating system?
We cannot decide.
So,
Right?
Sir,
Huh?
is cloud computing or cloud gaming comes under distributed OS?
Yes, absolutely true.
Then
Now, my dear students, we are going to use a term that is called process. Can you just tell me what is process? Any idea what is process?
Sir, it's a program which is currently in the main memory.
Yeah, a program under execution is called a process. What is the basic difference between program and process? Any idea?
Program is like lines of instruction of lines. A process is that execution of that lines.
Very good. Anything else?
Sir, program will remain in the secondary memory, but when it comes to the main memory, then it becomes process.
Is program require CPU?
Yes, sir.
Program
No, sir.
that is just stored in the secondary
Because
memory.
the program is not executed, so it doesn't require. But when it needs to execute, then it must go into memory, and then it needs CPU.
And from a program, can we created only a single process or the multiple process from a program?
So we can create multiple processes.
Multiple, because it depends on the how much content we are going to load on the main memory. Okay, so a program under execution is called process. Fine. That simply means a set of instructions which are there in the main memory. Fine. Now each process, keep in mind, my dear students, having some attribute. That means process have various attribute, various state. What do you mean by state? We will discuss. Various operations. Example is, if I talk about attribute, the first one is process ID. Process ID. So it's a unique ID which is given by the operating system to a process. Given ID number or identification number which is assigned by OS at the time of process creation. Fine. The next attribute we can say process state or priority of a process. Next is like the program counter. What is the purpose of program counter? Anyone? Basically, it contains the address of next instruction which is going to be executed. Fine. Now, all these attributes are basically stored or in a data structure that is called process control block. That means all attributes are stored in process control block. And keep in mind, my dear students, this is very important. Each process has its own PCB. This line is important. Are you getting my point?
So,
Fine. Now let's talk about the states of a process. Again, very important topic. Various state of a process. We are going to discuss about some of the state, but before that, I'm just creating a diagram. Fine. Can you just tell me in this diagram how many number of states?
Right.
Five. Five, sir.
5 states. So that is new, ready, running, termination, and wait. Can you just tell me what is termination state?
Termination state is the state when the process completes the execution.
Complete its execution. Okay. And so why not it's from wait or ready or new?
So because when the process is at the termination, then it cannot go anywhere. Can't go back to the other state.
Very good. That's why when it is executing, then after when it is running, after running, it is going to be terminate. So can you just tell me what is IO request? Okay, let's start. I think one by one. What is new state first of all? It is a state when process is being created. OS is going to assign some IDs. Linking and loading is going to be done there. Fine. So it is in the new state, the process is being created. And at this moment of time, operating system allocates process control block. and it also assign process ID. Fine. And the important point, most important point, memory is not fully allocated at this moment of time. So it is under the process of creation. In that moment of time, it is called new state. The second one is ready. So that means now the process is loaded into the main memory. So now it is waiting for the CPU because CPU means running at the running state. First process is like it is under the things of creation. Once process is created, it is reside in the main memory, that means in the ready state. There is this chance that currently CPU is executing something, so CPU is not free, single processor we have. Once that task is completed, then P1 move to running state. Are you getting my point?
Yes, sir. Yes, sir.
Yes, sir.
Yes.
So the process is being loaded in the main memory. It is waiting for the CPU. Can I say it is ready to run but not currently running? Yes or no? Whatever the process which are there in the ready state, they are ready to run, but not currently running, but not running currently. Yes or no?
Yes, sir.
Yes, sir.
Very good, my dear students. So, can I say multiple processes can reside in the ready state?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
That is, multiple processes may be in ready queue. Fine, fine. The third one is running. In this, the process is in there, the process is executing, as simple as. The process is executing, and if it's a single process, that means only one process in a single processor, then I can say it's only one process can be running. Yes or no? On single core CPU.
Yes, sir.
That means,
Yes,
Sir.
sir.
yeah, very good. Now can you just tell me what is waiting state? We can call waiting state also as a blocked state, keep in mind. What is waiting state?
Process will be waiting until another process will complete, sir.
Mm-hmm. No. waiting state. Now see, one process is in the running state and it requires some IO command, input output commands. Fine, maybe it is going to take the input from the keyboard, or it is going to like reflect something on the screen. So it required input output devices. At that moment of time, the process is moved from running state to waiting state or block state. That means the process cannot continue execution. Fine. When process required some input output, then it moves to, or not, then the process move to, then the moves from running to waiting. That is the important. Now, my dear students, see, from running, we are moving to waiting state because we require some IO request. Fine. At that moment of time, if some process in the ready queue that is going to be moved because we don't want CPU to be ideal. Yes or no?
Yes, sir.
Now, fine. Now, at that, it means if one process is moving from running to waiting state, still we have some processes. Yes or no? And now, can you just tell me, after completing the request of input output, it has to move to ready or running?
Both will happen, sir.
It cannot go directly to running.
We cannot directly go move to the running. Are you getting my point?
Sir.
Fine. That's why now what happened? One state is called running. A process is running in that state. Then it requires some IO. It moves to the wait state. That's absolutely true. Now, after some point of time, IO task is completed. Then it has to move from waiting state to ready state, my dear students, because again it is ready. Why it cannot directly move to running? Because there is a chance that at that moment of time some other process is going to be executed which is selected from ready queue. आ रहा है नहीं आ रहा समझ में?
Yes, sir.
Yes, sir.
Very good. That's why, so again, if I like enhance this diagram, then we have two more state. One is suspended waiting. In the similar way, suspended ready. Fine. Why there is a requirement of suspended waiting? Can you just tell me?
It is used to reduce the load on waiting state.
Okay. Because if there is a lot of processes which are going for waiting, then If the resources are not available, then it has to move to suspended waiting, my dear students. And from suspended waiting, at some point of time when some of the processes completed their task of IO, then they are moving from the suspended waiting to the waiting state. In the similar way, at the ready state, if my queue is full, because processes came one after another, na, if my queue is full, then where to keep all those records? That's why we make one more state that is called suspended ready state. Yes or no?
Yes, sir.
That's why it's a actually 7 state diagram, not 5. But in general, it is 5. Waiting and block. And last one is termination. That means process complete its execution. Yes. Is it fine?
Yes, sir.
Yes, sir.
Yeah. Very good. Now we have one thing that is called dispatcher. Can you just tell me what is the task of dispatcher? Here I am writing dispatcher.
No, no, sir.
Yes. Yes.
No, no, sir. No, no, sir.
No, no. Very good,
Yes,
my dear. So, my dear students, we know that in the ready state, we have the ready queue. Yes or no?
yes, sir.
Now, in ready queue, we have multiple processes which are waiting for the CPU. Means they are
Yes,
ready to execute. Now, suppose that CPU completed one task. Now, CPU is in ideal state. Now, which process is going to be execute next? Because in a ready queue, we have multiple processes are there. Now, it's the task of the dispatcher, which is a component of OS. That means it is a task of the dispatcher to select a particular process and move from the ready state to the running state. Are you getting my point?
yes, sir.
Basically, it is a component. CPU scheduler means dispatcher. Even we have different terminology also for the scheduler, that we have mainly three type of scheduler, but the dispatcher means like dispatch a particular process from the running state to the ready state. Fine. Now see, my dears, now I'm discussing again one more important point. So this is new state. So my dear students, can we make the class? Can we continue our class at 8:30? From 8:30? I think it's too late. 9, then till like 10:30. Is it possible for you?
Like 8:30 to 10, sir.
8:30 to 10.
Okay, sir.
Okay, sir.
Okay, sir.
Right?
Yes, sir.
Maybe I'll discuss with the management, and if there is any updation in the schedule, then my dear students, please join at that moment of time, okay?
Okay,
Yes,
sir.
sir.
Because sometimes it's too late in. So see, my dear students, we have mainly three type of scheduler. Scheduler is again a program, okay? Fine. Now they have their own different functionality. Like one's task is to, okay. Again, I can say it is a set of program, or it's the part or the component of the operating system. Scheduler mainly task is to decide which process should run next. So scheduler is a again component of OS that decides which process should run next. So mainly we have three types of scheduler. The first one is long term. Fine. Second term is short term, and third one is medium term. Now let's go one by one. What is short term scheduler? Short term scheduler mainly works in this area. Short term scheduler. Long term scheduler. Oh, sorry, what I'm. It's a long term. Long term scheduler. Here we have short term scheduler, and here we have mid term scheduler. Not here. Actually, mid term scheduler is here. Fine. Now, what is the task of long term scheduler? So it decides which jobs are admitted into the ready queue. It means from the running to the ready states, what are the set of processes which are moved from new to the ready state? This selection is done by long term scheduler. Are you getting my point?
Yes, sir.
Yes, sir.
Yeah. Now see, my dear students, we have mainly two type of process. One is IO bound process, and the second one is CPU bound process, my dear students. Can you just tell me what is CPU bound process and what is IO bound process? Any idea?
No, sir.
Oh, sir.
See, my dear son, when a process take most of the time in the IO activities, then that process is called IO bound process. When a process required most of the time the CPU but not the IO, then that is process is called CPU bound process. Is it fine?
Yes, sir.
In short, most time requires CPU. Most time require IO. Are you getting my point? That's called IO bound process or CPU bound process, my dear students. Now see, suppose that the long-term scheduler only brings CPU bound process. What is the problem? Can you just tell me? What is the problem if long-term scheduler always select the processes which are moving from new to ready state and the process is IO bound process? What happens?
There is starvation. Means CPU will be idle and there will be starvation for the processes which need CPU.
Yeah, that means CPU is ideal. Fine. So if long LTS means long-term scheduler selects IO bound process, then then CPU is free most of the time. So throughput decreases. Are you getting my point? What if it generates only CPU bound process?
So then throughput will be high. It means CPU will always be busy, but the processes which need IO bound they will starve.
Yeah, they require more time, right? CPU bound process means most of the time is be there in the CPU. That is the main point. So the task is like if long-term scheduler only brings always IO bound process or CPU bound process, then always we have some disadvantage. In IO bound processes are or CPU is ideal. In CPU bound process, what is the problem?
IO bound processes will be starving.
So throughput decreases because each process require most of the time the CPU. Suppose that one process, the starting process will take a lot of time to complete. So overall throughput decreases. That's why it's the task of long-term scheduler. Keep in mind, it's the task of long-term scheduler to bring the processes which are a mixture of IO bound and CPU bound. Are you getting my point?
Yes, sir.
So it's the task of long-term scheduler to bring a good mixture of CPU bound and IO bound. Are you getting my point, my dear students? Processors. Yes or no? That's why, my dear students, the most important point is LTS long-term scheduler controls degree of multiprogramming. Are you getting my point?
Yes, sir.
That is the most important point. It's the task of the long-term scheduler to bring a good mixture of CPU bound and IO bound process. Fine. Okay. Suppose that like we are like loading 50 jobs from the secondary memory or the disk to the main memory, but we are only selecting 10 for ready queue. This type of task is done by long-term scheduler. Now, again, very important. Now we have a lot of processes in the ready queue. Now comes into the picture short-term scheduler because it has to take the decision as soon as possible. Once the CPU is ideal, it has to take the decision as soon as possible so that the ideal situation of CPU is very less. Fine. So that's why it is called short-term scheduler. Now, what is short-term scheduler? Decides which ready process will get the CPU next. It means it's the task of short-term scheduler to select. We have many processes. Suppose it select P3. Now it's the task of the dispatcher to dispatch this process and move to the running state, my dear students. That is the task of dispatcher. Are you getting my point?
Yes, sir.
Sure.
Yeah. Can you just tell me why I am writing this backward arrow?
If any process failed, it returns to ready.
Okay. Other than that,
Sir, if any
If
process,
the
any high priority process which is there in the ready queue, then there can be preemption. Means a priority process can go into the running state, and the low priority process can go back to the ready state.
okay. Then yeah, very good. Because suppose that right now a process is running. Okay. So and the priority of that process is somewhat low, and a new high priority process comes into the picture. Then because because the low process doesn't require any IO request, that's why it is not moving from the running to the waiting, but it has to move from running to again ready state, my dear students. We are going to preempt that particular process. Are you getting my point?
Yes, sir.
Yes or no? Okay, that is the main case, my dear students. Yeah. So if I talk about decide which ready process will get the CPU next. Very good. So if I talk about medium term scheduler, can you just tell me what is that? It's the responsibility of suspending suspended ready and suspended wait. Suspend no, or better to say, responsibility of suspending and resuming the processes. Are you getting my point, my dear students? What's the main task of medium term scheduler?
Yes, sir.
Fine. Dispatcher we know, preemption we know. So from tomorrow onwards, we are going to start the important point, that is CPU scheduling or job scheduling. Okay. We have many types of job scheduling. Before that, we will discuss what the starvation means, and then we will just solve one numerical problem also. That's the key point. Okay. So that's all for today's class.
Sir,
I'll
can
try to.
you explain preemption again?
Preemption means that a process is there in the running state and it is in the executing state. Okay. Preemption, and we have mainly two type of process. One is preemptive process. One is non-preemptive process, my dear students. Preemptive means we can stop in between. Non-preemptive means a process, if it start once, it has to complete its all the task and move to the termination states. No one can preempt or stop them at the intermediate stage. Okay.
Yes, sir.
Okay. Okay, my dear students. Thank you.
Sir, can you I mean, tell me the question of the various state of process. I mean, can you tell me the question?
What question?
I mean, जैसे कि एग्जाम में क्वेश्चन आएंगे उस तरीके से क्वेश्चन.
एग्जाम में आ सकता है, what is the purpose of new state?
Okay.
What is the purpose of LTS, STS, MTS? What is the task of dispatcher? Okay. What are the different types of operating system? They may give you an operating system which are bound to its deadline constraints. Is an example of, or is a type of real-time operating system.
अच्छा.
Any doubt?
No doubt, sir, but no doubt.
No doubt, but means
सर कोई डाउट नहीं है, बट जो क्वेश्चन होंगे उसको एक बार देखना है इस तरीके से.
okay. Sure.
फिर उतना हमने पढ़ना है ना.
हाँ बिल्कुल. रेगुलर टेस्ट अपलोड हो रहे हैं. यू कैन ऑल्सो अटेम्प्ट द टेस्ट.
हाँ जी सर.
Okay. Okay. Thank you so much, my dear students.